In this question, we're asked which statement is correct. The answer is C. Bear in mind that electrical heaters, their waste energy is heat, but that is also the job of the electrical heater, so therefore they could be 100% efficient, assuming no sound or other forms of energy. It's not A, because the kinetic energy changes sign. Well, kinetic energy is a scalar, so it doesn't have a sign, so that's not right. This is, it's not B, because it drives up at a steady speed. So this is the power generated by the engine equals the potential energy gain per unit time. There will be other forms of energy as well being output by the car, heat, sound, and so on. That's not right, and this is just always wrong. The next one was question 12. It says, what is the kinetic energy lost during the collision? So first of all, the kinetic energy before, just a half mv squared for both. So half times 5,000 times 2 squared plus half times 5,000 times 1 squared. Then we need to find the kinetic energy afterwards. Now, to do that, we need to find the velocity afterwards. It shows that they collide and stick together. So let's do conservation of momentum. Momentum before, so this is positive and this is negative. So right is positive, left is negative. Momentum before is going to be 2 times 5,000 plus negative 1 times 5,000. So that's going to be 5,000 kilogram meters per second of momentum before. It's going to equal the momentum afterwards. Afterwards they stick together, so their total mass is the sum of the two masses, so 10,000 times by the velocity. So that gives us a velocity of 0.5 meters per second. So now we need to find the kinetic energy afterwards, which is equal to half mv squared. Half times by the mass afterwards, because they're stuck together, times by the velocity, 0.5 squared. That will equal 1,250. The kinetic energy before will equal 12,500. So if you subtract that from that, you'll get an answer of C. In this question, you're asked to find the average force. This is equal to the rate of change in momentum. We know the time, 0.1 seconds. We just need to find the change in momentum. It's going to be equal to the momentum afterwards minus the momentum before. Momentum afterwards, now let's give directions to these. Let's say left is positive, right is negative. So that's negative, that's positive. Momentum afterwards is going to be 0.5 times by 8 minus, and then 0.5 times by minus 12. So this is 4 minus negative 6. 2 negatives equals a plus, so this becomes 10 as the change in momentum. Put that back into the equation. 10 divided by 0.1 will give you 100, and that is the force. For this one, you're asked which of these is not consistent with the principle of conservation of momentum. So for this, work out the momentum before. So that's going to be, and again we need direction, so let's say right is positive and left, excuse my pen there, is negative. So this will be plus u and this will be negative u. The momentum before is going to be 2mu, mass times velocity, plus m times minus u. So that's going to end up with 2mu minus mu, which basically equals a momentum before of mu. So all you're doing in these ones below is working out the momentums using the same directions and working out which one is not consistent with it. To speed this up, the answer is B. So let me show you why. Here, again, we're saying right is positive, left is negative. So we've got negative 2mu over 6 here. We've got positive 2mu over 3. This is the equivalent of 1 negative 1 over 3 mu. And if you add those two together, negative third mu plus 2/3 mu, and that gives you a third mu. So you can see that does not equal the momentum before, so it is not consistent. So B is your answer. In this question, you're told that the collision is perfectly elastic. A reminder that for perfectly elastic collisions, the relative speed of approach equals the relative speed of separation. So the relative speed of approach before the collision is going to be one of the velocities added to the other, because relative to each other, they're approaching each other at the speed of u1 plus u2. So this was 1 metre per second, this was 2 metres per second, and they're coming towards each other, then the relative speed of approach would be 3. So that leaves us with C or D. Most of you had gone for B or C. In the second part, after the collision, the relative speed of separation is going to be one of the velocities minus the other, okay, because they're both moving in the same direction. Say this was 4 metres per second, this was 2 metres per second. Relative to each other, they'll be going 4 minus 2, so 2 metres per second. So that leaves us with option D as our answer. In this question, sand is added to a truck. The sand is falling down, so it will have momentum in the downwards direction, but we can ignore that because we're not worried about the velocity change in that direction. So it really has initial momentum, or momentum in the xy direction is equal to 0 because it's falling vertically down. There is no momentum in the left-right direction. So when it enters that track, the mass is going to increase, and the momentum before will equal the momentum afterwards, so the velocity is going to go down. So we know it's either A or B. So now they're both moving together, and the sand falls out. Now when the sand is released out the bottom of the track, which I'm showing here, it's going to still have that momentum in the right direction. So actually the velocity of the truck will stay the same, because I suppose the amount of momentum per unit mass is staying the same. That sand is falling out, and it's still moving to the right with the same velocity. If you don't believe me, hold a pen, move it across your desk at constant velocity, release the pen will keep moving at the same velocity it initially had. The answer here is B. This question, very 6, is just a conservation momentum. So work out the momentum before, but just bear in mind that they're going in opposite directions. So let's give one of them a positive value. So I'll make this positive and this direction negative. So the momentum before will be 6 times 20. The momentum the momentum of the first vehicle will be 6 times 20. The momentum of the second vehicle before will be 12 times minus 15. That will give you the momentum before, which will be equal to the momentum afterwards. Afterwards, they've stuck together, so their total mass is 20 plus 12, so 32, times by the velocity afterwards, which is what we want to find. If you solve that, you should get answer as A. A lot of you got C, which I'm guessing is because you didn't include the direction element in that. In this question, we're asked to find the magnitude of the change of momentum of the ball. That means the change in momentum, and the magnitude just means we don't need to worry about the sign. Change in momentum equals the momentum afterwards minus the momentum before. Momentum at the end, now remember we need to give these signs, so let's say right is positive, left is negative, doesn't matter what you choose, as long as you're consistent. So the mass of the ball is 100 grams, which is 0.1 kilograms, times by the final velocity, which is negative 30, and that's taken away from the initial velocity, which is 0.1 times 20. So that gives us minus 3 here, and minus 0.1 times 20 is 2. So minus 3 minus 2 equals minus 5. So the change of momentum is 5, a magnitude of 5 kilogram meters per second, and the minus tells us the direction, but that's not what the question is asking, it just wants the size. Most of you went for A, so that means you weren't careful enough with your signs.